See that on cars, but obviously you haven't got that on the bicycle, have you? An RPM counter. Happy with that? Good. Now, the next really good bit coming in here is you then need to know what's meant by angular velocity and time period. Well, I've mentioned already, this is going to be your linear velocity here, which is going to be the v. Okay, and that, remember, is if you dislodge something here, where would it go? It would dislodge itself from the perimeter, going a straight line along here. But we now need to get our idea of angular velocity. Well, the angular velocity is how much of an angle is the object going to create going from here, going from A to B in time t. Now it comes out a weird symbol. The symbol is called omega, and I'll spell it for you. Remember, we like to use Greek alphabet to make ourselves look nice and intelligent, and it comes up here. And omega is defined as delta theta over delta t. To remind you, before we said v was going to be delta s over delta t. What I'm doing now is taking the distance into an angle. Now, what we do, and this is why the prep work we brought this out, is we measure the angle now in radians. We don't use degrees. We use time in seconds. So what happens now, this is going to be rads per second. Okay? Now, the other formula, which you should have seen in your textbook already, pops out as this one here, 2 pi over t. Why? Because if I'm starting here at point A, if I go all the way around, the angle I'm going to arc out, as a terrible arc there, is going to be 2 pi, because it's gone through one complete cycle. We've looked at this at ways, haven't we? Yes, we have. Therefore, isn't it then going to say the angle is going to be 2 pi, and therefore isn't then the time it takes going to be t? Another way you can write that, don't I know, frequency is going to be 1 over the time period. Yes. Therefore, doesn't it make sense that omega equals 2 pi f? These are derived equations. You don't need to memorize them. All they're doing is completing what we did before. But hang on. Now, looking at this one, it says starting to cough to death. That's my throat. Don't I know already that v equals 2 pi r over t, correct? Therefore, hang on, haven't I got this bit already, that 2 pi over t, because I know omega equals 2 pi over t. Doesn't it make sense now? Hope you're appreciating my colour. The v is then going to equal to omega r. This equation comes from, all you're looking at is 2 pi over t. Now this starts making sense because as it goes around the circle, wherever you go along your little line here, omega is going to be constant because you're going to arc out the same angle in the same time. But isn't the linear velocity going to increase? Because here v is going to be big, and here v is going to be small as you come towards the center. Therefore, as the r increases, the v increases because omega is constant. Can you see that? I repeat, v increases, goes out because v gets bigger, r gets bigger because omega is constant. And if you're going around, I'm sure you do occasionally, fairground rides or the playground, you see a roundabout. And you go around roundabout, if you actually put yourself here on the furthest part from the center, it feels like you're really shifting because your radius is bigger. Got it. This equation here, I can't remember which one is the formula sheet. That wasn't there. That might be in the formula sheet as well, but it's an easy one. It can make sense. It's derived. So again, to finish off, what I'd like you to do is I would like you to stop the video and I'd answer these questions. I'm going to show you the answer in a second. So you've got a model car moves around a circular track at radius is equal to 0.3 meters, and you've got 2 revolutions. Whoops, can't write here. Try again. Is then going to be revolutions per second. Calculate angular velocity, time period, and linear velocity. Stop the video. Do it. Welcome back. Hopefully you stopped the video. Now, so first of all, Well, I start basically jotting down my equations. Okay, I want the angular velocity. I want omega equals 2 pi over t. And then straight away, well, I need time period to do that. But hang on, what you can do is you can answer these in any order you want to. If I know I've got 2 RPS, isn't the time period simply going to be 1 over t2 or going to be 0.5 seconds? Therefore, if it takes 2 revolutions per second, 1 revolution is going to be half a second, isn't it? Makes sense. Therefore, straight away going here, omega then equals 2 pi divided by 0.5. Now you start seeing this in multiple choice. Sometimes they leave the answer in terms of pi. And that is actually a better way of doing it because you haven't got to worry about rounding up the numbers because it's all contained in pi, which you say 3.146, etc. Yes, and you're quite legit to leave it like that. So I can straight away, time period with 0.5 seconds, angular velocity is going to be then 4 pi. Linear velocity, well, I can simply say v is equal to omega r, and then what I can do is I can take my omega, which I know already is going to be 4 pi, and then what I can do is multiply it by 0.3, which is going to be my radius, which then isn't that going to be 1.2 pi? Try getting that there. Again, and then that's going to be meters per second. You can easily use the equation v equals 2 pi r over t. That's exactly the same. It leads to the same result. And obviously then you've got your 2 multiplied by pi. The radius is going to be 0.3. And you divide by the time period 0.5 to give you the right answer. That's a shortcut way of doing it. 1.2 pi. Okay, so I think that's going by next lesson. So what we've done, to recap, is we've gone through that equation there. We've gone through this equation here. And what we've been able to do is to find angular displacement and angular speed. And we convert angles from, well, we haven't done that. That was actually part, to be honest, in your prep work. Hope you enjoyed the video.